Hello. Good morning, ladies and gentlemen. Here we are, Science 8, and we are going over the worksheet that I published yesterday, sent out yesterday, and just to further explain some of the things that are perhaps there, answer some questions. So, Science 8, atoms in the periodic table, solutions. So, we've been talking about atomic models. And we've gone through sort of the history, the idea starting sort of with Dalton. It really started way before him, which is really kind of fascinating in itself. But we really started with Dalton, and because Dalton sort of gave us the idea that an atom was like a pool ball, a small, round, hard, spherical object that you couldn't cut in half any longer. But then, problems happened. It doesn't matter how many times you prove something to be true. If you can prove it to be false once, then the other true times don't really matter. Thomson discovered the electron. And so while the atom still really acted like a pool ball, what he said was that it now had a bunch of negative electrons that were basically embedded in it. And that's where we get the idea of, a chocolate chip muffin. We've got the muffins inside there, or I sometimes think of it like a poppy seed muffin. Then you have Rutherford. Rutherford was a student of Thomson. And what Rutherford is known really, well, he's known for lots of things, but what we're looking at him for is in terms of the gold foil experiment. And the gold foil experiment said that, okay, here's our atom, but within the, basically, that's the nucleus, and that's where the mass is, and that's where it's positively charged. And then out here, you've got some negative stuff. But, this stuff is really, really not very much compared to this. And what we have in here is really empty space. And I always tell students that, if your parents sort of say, what do you got between your ears? You can sort of almost be truthful and say not much, because the atoms that make up between your ears are mostly empty space. And so Rutherford had there were some issues in terms of electrons being around here. Why don't they just fall in, be attracted towards the positive nucleus? Because they're negative and collapse and big burst of energy. And so Bohr came along, and Bohr basically said they don't. And what they do is that they exist in these orbits around there. So this is the progression. From a chemical physical point of view, it's always like a pool ball. But how things are arranged inside here through Thomson, Rutherford, Bohr, and beyond into wave models and so on, just show more complications. Now, the video that I had you watch Tuesday really was talking about the size of the atom, and really the idea that things are small. But in terms of the size of the nucleus, they talked about a blueberry the size of a stadium having a marble-sized nucleus. And that's even really too large, much too large. It can actually draw a nucleus that size. But, I always like giving people the idea of our gym. And, our gym is, it's not huge, but it's big enough that you can play basketball in there and stuff like that. And then think within that gym, a fly flying around in there. And that's probably close to the size, similar to the size of the nucleus within an atom. And it sort of gives an idea. Now, Rutherford was the one who actually came up with the analogy of the size of the nucleus, and he talked about the fly in the cathedral. And a cathedral is, if you go to Europe, a cathedral is just a big, big church in the idea of fly being in a cathedral. We don't really have too many cathedrals in North America, but Europe, they have them all over. All right, so then that brings us into subatomic particles, the electrons, protons, and neutrons, really the order in which they were discovered. So electrons have a negative charge. And what is charge, and where do you get the idea of charge? Well, think about taking a balloon at your birthday party, and you take your head, and you got hair on your head, and then you rub the balloon on your head, and then you can take the balloon and you can stick it to the wall. And that's because there is an attractive charge that happens between the balloon and the wall, uh, and that's a static charge. And so we talk about static charges, positive and negative static charges, and if you have negatives and negatives or positives, they repel, they push against each other. And if you have a positive and negative, they attract. They get pulled towards each other. Now, we're not spending any time in Science 8 talking about electrostatics, but it's just a good idea to have a little bit of background. So electrons, they negative charge, they're going to be repelling, and these things were found to be very light. And the analogy I gave was like 6/4 to your body mass, how much you weigh. The electrons weigh approximately almost 1/2000th the mass of a proton. That's where I did the calculations to come up with that many quarters. About 6/4 to about 100 pounds. Location of the nucleus or the atom. Electrons fill the atom. They fill the space really within the atom. That's where they exist. Protons positive, P and P. That's how you can remember that. They are heavy, and they're in the nucleus, that very small fly-like thing. And then we have the neutron. Now, protons were discovered early 1900s. Neutrons were not really discovered until 1932. And that's about 87 years ago. Just being neutral made them really, really difficult to detect, to know that they're there. And so that, yeah, it makes it, they were late to the party, as I would say. They have no charge, and they're heavy. They are just slightly heavier than a proton, and they're also located in the nucleus. What they do is they help the stability within the nucleus. I think I may have mentioned that. You start messing around with neutrons, you can make things radioactive. But it's the protons that define the element. So, the periodic table. Now, the periodic table has a sort of a strange shape to it, and it didn't always have this shape. The person who came up with this shape was a Russian named Dmitry Mendeleev, and how he set up the periodic table was much different. But what we have is that we have rows going across, and these rows are called periods. And there are 1 to 7 of the periods going across. These two ones down here actually fit into a section here. It doesn't work really on a piece of paper. But you've got these 7 periods of the periodic table, and we count going 1, 2, and then we come down 3, 4, 5, 6, 7, 8, 9, 10. And we come down 11, 12, 13, and so on, going across. We keep on going left to right, going across the periodic table. Grade 11, if we come to chemistry in grade 11, we learn more about what we call the electron configuration and the impact that has with the shape of our periodic table. There's a lot of information that's in here. And so, yeah, we've got the periods going across. And then we've got columns. And these are called groups or families. Some of these are named, and on the periodic table that I gave you, you'll see the names just listed down below. Anyways, you have these groups or families. What we find is that characteristics, properties of atoms change gradually as we go across the period, and they're similar within a group. And so all of the group 1 elements over here, they all react quite violently with water and so on. That's part of their properties. They take on +1 ion charges and so on. Here we have group 2, and they have similar properties. Over here we have group 18. So we go from 1 to 18 over here. These are called the noble gases, and they don't do much. But so this is really the periodic table. And so on the periodic table, I talk about the elements being made up of cells. And so you've got, cells such as element number 8, and that's oxygen. And has a certain amount of information within there, and we can learn from there. So up here we call the atomic number, and that's the number of protons. And that can also be the number of electrons if it's a neutral atom. Okay, so the number of same amount of positives and negatives. This is the symbol. Now, the symbol generally comes from the name or sometimes from the Latin name. Latin was the language of science. And so you get things like Pb for lead. And where does Pb and lead come from? And it's just not there. Anyways, then we have the name, oxygen. And this is what we call the atomic mass. Now, again, grade 11. We deal more with that and deal with this. And then up here, we have the possible ion charges. So this tells us oxygen will take on a -2 charge. So we can talk about an oxygen atom, or we can talk about an oxygen ion. So this would be an atom, and this would be an ion. And the idea of having 2 negative, well, it means that there are 8 protons, and there's always going to be 8 protons, but in this case, there would be 10 electrons. And so because we have 2 extra electrons, and electrons have a negative charge, then we have a 2 minus charge. Okay. We're not spending a whole lot of time on this, but just to recognize each one of these cells represents the information for that atom and so on. And again, here we have the key that describes what the information is within here: atomic number, the symbol, the name, atomic mass, and the ion charges. And you can see that some elements have more than 1 ion charge. 2 and 3, and I think there's one down below that has like 5. Well, there's 4. And so maybe 4 is the most. And that's not to say that these are all of them, that these would be the common ion charges for this. Sometimes there might be some other ones that show up. Now, again, grade 11 might give us some idea why there are these different ion charges. So don't worry at this point. This is just really an introduction, periodic table of elements, really important to chemists, really important in terms of showing relationships between elements. You don't ever have to memorize the elements of the periodic table. You'll always have a periodic table if you need it on a test or quiz or something like that. This is just shows that. And really, again, what I'm trying to show is that there is a relationship between the atoms and the atomic models and what they're made up of: protons, electrons, and neutrons, and what we have in this periodic table. And so we're up to element 118, and this, in essence, is what matter can be like anywhere in the universe, made out of these 118 elements. All right, so then we come down to here. I did the first one for you. The idea is zinc has the symbol Zn, atomic number 30, 30 protons, 30 electrons, possible charges 2. Oxygen, if we go back, that's not what I wanted. If we go back, here's oxygen. Oxygen is element number 8, -2. So oxygen has the symbol O. Atomic number is 8. Number of protons is 8. Number of electrons would be 8. And possible charge 2 minus. Then we have C. C is carbon. And again, we go back to here. So here we have carbon. Here's oxygen. Here's carbon. How do you know where carbon is? Well, you can look on the periodic table. You can find the names and so on. lot of times I would give you an alphabetical list of the elements, and I would help you find them as well. But here again, we're just making use of this and letting you go through. There's only 118. All right, here's carbon, 6, 12, no charge up there. So we've got carbon C, so it has or atomic number 6 protons, would have 6 electrons. Impossible charges, we're just leaving that blank. Then we come to element number 11. Well, how do we know where element number 11 is? Well, we count 1, 2, 3, 4, 5. Okay, here's element number 11. Na, sodium, 23, 11 plus. That plus means plus 1. That's a good point. All right, so we have sodium. Symbol is Na, has 11, atomic number of 11, 11 protons, 11 electrons, and can take on a plus charge. I often tell students, we don't write ones in chemistry. So this means that there's one positive charge to this, but a positive one charge to this, and that it can possibly take on. But they just write the plus rather than 1 plus, because if they've written the plus, that means there is the 1. I just say we're saving digital ink supplies. All right, number of protons is 92, which means the atomic number is 92. The number of electrons would be 92. Well, what's element number 92? We go through, where's 92, 76, 80, 86, 87, 88, 89, 104. Come on. And then we realize, oh yeah, we have to go down. Here's element number 92, uranium, 6, 4, and 5, 238. So we have uranium, 6, 4, and 5. Then we have 26 electrons. So that would mean we have 26 protons. We're not creating ions at this point. And an atomic number of 26. So we need to find out what's element number 26. Oh, here we go, 26, Fe. Fe is iron, 3 and 2. So we have, I did this one backwards. That's okay. Iron, we have Fe is the symbol, and there's our 3 and 2. Okay, I'll fix this. You guys are like, stop yelling at me. Mr. Johnson, you did it wrong. Okay. All right, here we have Pu. Pu stands for plutonium. You can't make up names. You got to find them on the periodic table. Now, I happen to know where here's plutonium, element number 94, 4635. Let's go 4, 6, 3, 5. I just forgot the number, and that was 94, wasn't it? Yes, Mr. Johnson, it's 94. Oh, thank you. 94, atomic number of protons, 94, number of electrons, 94. And that is it. Woo-woo. So check your answers. Again, if you have questions, contact me. Send me an email. Come on to Jitsi. There's various ways and various things that you can do to get contact and get some help. Have a great day, ladies and gentlemen. Looking forward to seeing you soon.